Good morning. My name is Paul Alemany. I'm a PhD student in the Centre Tecnològic de Telecomunicacions de Catalunya, CTTC, and in collaboration with Thales, I'm going to present the following paper: Transport Network Slices with Security Service Level Agreements. This presentation is divided in 5 sections. First, I will present the objective of this paper and presentation, then the main concepts to understand the context in which this paper was done. We will enter into the focus and the main point of this presentation, the security framework for network slices. And once this architecture and design is presented, I will introduce a simple use case to understand better how this works. And I will finish with the conclusions and future tasks. First of all, the objective. The objective of the designer that I want to present is that the designer security manager, or the security framework that I want to present, aims to enforce and manage security functions to add security characteristics and requirements to transport network slices. Also, another objective that for this presentation is to present how the relationship between inside the framework that I'm going to present, which is composed of 2 elements, the security manager and the network slicing manager. And the idea is to present how they're related. And with their relationship, finally, to present how secure transport network slices will be deployed and monitored. The main concepts, first of all, is the network slicing. Network slicing is a set of interconnected network services. They can be shared or not among slices. And each set of network services will be deployed virtually in creating a virtual network over the physical network. So each slice will have a virtual network that will be placed over the physical network. Network slicing is managed by using 2 elements: network slice template, which is a descriptor with all the elements in the slice, network services, the functions, and how are they related, and the network slice instance, a record based on the network slice template that also includes the information of the virtual elements, such IP addresses, IDs of the virtual elements in order to manage them, and so on. Network slicing classifies the slices in 3 types, as you can see, as I can present. And to make it more descriptive, as you can see in the figure, you can see that the slice is a single unit with a set of network services on the 2nd level, and it follows the same idea that the network service, the network service is a set of virtual functions, as you can see on the bottom of the figure. The next idea or concept to know is security service level agreement. A service level agreement is a contract between a service consumer and service provider, in which the second has to ensure the fulfillment of a set of requirements for the first one to get the expected quality of service. In our case, we will focus on security SLAs, and to work with them, we will use the specs SSLA model. This model, as an example, is based on 3 aspects: security control, which defines what the SSLA will control, the metrics of the SSLA, what has to be controlled, or the parameters that will be the metrics, sorry, the parameters that will be needed to control, and the SSLOs, which are the values to control. So, for example, in our case, a multiple factor authentication, it is needed set a number of factors, a number of elements for authenticate, and the SLO is 2. So we will need 2 elements to authenticate the user. As this was the model based on network services and functions, in our case, we have to extend it to support slicing. Based on the previous model, the idea is to extend it using slice resource providers, which will define which elements within the slice deployed which elements are affected by each SSLA selected. And in addition, also, the slice required security capabilities. What does it mean this? Yeah, capability, we define it as a set of security controls. So we might have a set of capabilities, and each capability will be a set of security controls in order to have different parameters to control of the slice. As we involve different services, it is necessary to define different security controls. We cannot have just one specific as before. And finally, the security metrics, which is related to the service level objective, in our case, security service level objective, and they contain the name, definition, and other aspects that you can see. Based on this, the security manager responsibilities using SSLAs will be to gather the verticals and end user security requirements when a slice is requested. A slice deployment is requested. With these requirements and the slice request, to deploy the slice, of course, the slice elements, and attach the necessary security controls and deploy the necessary elements to enforce the expected SSLA, and so the third responsibility can be done, which is to monitor in real time the fulfillment of the selected SSLAs. Finally, the last two responsibilities are, first of all, to detect violations of any SSLA, and if any violation happens, to look for the correct policies and actions to correct and solve the violation in real time. With the context and the main functions of the security manager defined, let me introduce the framework that we are working with. On one side, there is the service manager, and on the other side is the security manager. These two are the two components composing the framework that we are designing. First of all, the slice manager is composed of 4 elements, 2 databases, one per each network slice object. On one side, the templates, on the other side, the instance records. Then there is a slice lifecycle manager, LCM, which is in charge to manage all the actions regarding slices. These will send requests to the slice to network service mapper will request as a slice whole unit, and this second element, the slice to network service mapper, will divide from a slice point of view to network service point of view. For each network service will send a specific request to the NFV orchestrator. So this can deploy the virtual elements composing the network service. Then on the right side of the architecture, there is a security manager. On the top, we have the AAA manager, which is in charge to validate the access of a user into the framework, into the security manager. Linked to the AAA manager, there is a database called users profiles with the users that are allowed to access. Then under the AAA manager, we have the SSLA manager, which right now is the core of the security manager. This receives the request and sends it to the slice manager, gets the SSLA manager also all the actions related to the SSLAs, and so on. It is associated to or linked to an SSLA database. So when it needs to get SSLA information, requests it to this database and passes to the information to the components that need it. Under the SSLA manager, there are 2 main parts. First of all, the security functions orchestrator that, based on the SSLA selected for each slice, will deploy the necessary proof that we are going to call security functions, because we will have not only proof but other elements. It will be in charge to request the deployment of the proofs to attach around or next to the components of the slice and get the information to pass it for the monitoring action. The security function orchestrator is attached to a security functions database, so the SSLA manager can request whichever security function that is in this database. In order to monitor, or when monitoring, all the proof will pass the information up to this part of the security manager on the left side of the figure. First of all, there is a data collector that will gather all the information in groups of on the corresponding groups and save it in the data services in order to keep track and logs of everything that has happened to the system, and pass the gathered information to the analytics engine, which, based on a set of parameters passed by defined by the SSLA manager, will detect if an SSLA is violated or not. If an SSLA is violated, it will inform the SSLA manager, and this act accordingly. Finally, there is one last database, which is Secure BNF Network Services, that will contain the BNF and network services that can be used to deploy slices. So if a slice request reaches this point and uses a BNF or network service that is not inside this database, the slice will not be deployed. This was done to add a first level of security even before the deployment. So the user or the slice owner and the user can be sure that the elements composing the slice are certified and they behave and they do what they were created to do. The following slides, I present you the basic elements that I just correspond to the architecture that I just described. Let's go into the use case description. It's, as said in the introduction of this presentation, it's a really simple use case to understand all the flows that I will describe later. It is a single slice, just one slice, composed with one single network service, in this case a firewall, and it has two security functions attached to the slice. On one side, there is a traffic generator, and on the other side, the traffic sink. The traffic generator will create random traffic that will be sent to the firewall, and those, based on the rules, the traffic that has to pass should reach the traffic sink, and the traffic that shouldn't pass should be blocked. The traffic sink, its responsibility is to get all the traffic and pass it up to the elements like the data collector in order for this to select and organize the information. So the flow when deploying a slice is that the user requests slice owner, a service consumer, or service provider request a slice request, access to the framework through the IEEE manager. If the requester has access, it will be approved, and its request will reach the SSLA manager. Then, as presented in step 3, then in the SSLA manager will get the information of the SSLA selected and forward all the information, slice and SSLAs to the slice manager, more exactly to the slice lifecycle manager in this module, in step 5. This, using the information saved in the NST database, will create the network slice instance object with the SSLA information and the NST information. Once this object is created, as step 8, will be saved and will start to request the different components of the slice, as step 9 shows, to be deployed. The slice to network service mapper, when getting a request per each network service, will check that they are inside the secure BNF network services. If one of them is not in this database, so is not secure, an error is generated, and the slice lifecycle manager is informed, also the SSLA manager, and finally the slice requested, as steps 11, 12, and 13 show. If everything is okay, otherwise, we will go to step 14, which is that the slice network service mapper will request to the NFBO all the network service, and this will deploy over the physical network. When everything is ready, the slice lifecycle manager module is updated and updates the network slice instance to the database. And as in step 17, informs the SSLA manager. So this can start applying can define the SSLA rules to the analytics engine. So the analytics engine as step 18 shows, gets the rules. So in order to compare any incoming information when the slice will be monitored. Then the analytic engine defines a set of parameters that want to receive from the data collector when this gathers information from all the proofs. When these two elements are configured, everything goes back to the SSLA, confirming that all the process was done, as in steps 20 and 21. And the SSLA manager deploys the security functions, also in this case proofs, request the deployment of these security functions to the security function orchestrator. This carries on the steps 23, 24, and 23 and 24, deploying, getting the security functions information and requesting to the NFBO to deploy those elements next to the different slice elements. When everything is okay, the service function orchestrator informs the SSLA manager that everything is settled, and this finally informs the slice requester that the slice is finally deployed and ready to be used, as steps 26 and 27. Then, with the slice deployed, the next action is to monitor the slice. In this case, the slice is ready, is working. The idea is that all the proof, or this action starts with the proof. The security functions, are continuously sending information to the data collector. In our case, the traffic sinks will detect those. Will send all the IPs that have reached that proof, that security function, and pass it to the data collector. This will collect all the IPs and pass it, as in step 2, to the analytics engine, which will validate all the IPs, and based on the parameters defined by the SSLA manager, will decide whether all the IPs until that moment were allowed to pass or not. If everything is okay, they were allowed, all the traffic was generated by IPs, by allowed IPs, as in step 16, nothing, no violation, and nothing, the analytics engine simply saves logs and keeps waiting for new information. If a necessary evaluation has happened, as in step 4, the analytics engine informs the SSLA manager, and this checks for the correct policy to apply. In this case, it will be to reconfigure the firewall network service. So this action to reconfigure is requested to the lifecycle manager in step 6, and this updates its network slice instance with the new information and requests to the network service mapper to reconfigure the network service. And this, as in step 8, and then in step 9, the network, the slice to network service mapper request to the NFB orchestrator to apply the necessary actions. Once everything is done, the responses are going back until the SSLA manager, which in step 15 has to keep checking if the policy is still has worked or not, with the new set of information that will arrive. If everything is okay, then we will be in step 16 that we keep waiting until a new SSL evaluation happens. Finally, as a conclusion, we presented a new security framework to focus on the security of end-to-end network slices for transport networks. This framework is composed on 2 elements: the network slice manager and the security manager. We also introduced the concept that called security function, which will involve not only proof, but will include proofs among other elements that can be associated to SLAs or the network services. Finally, I just presented a simple workflow or the workflow of deploying and monitoring a simple use case to understand better this framework. Some work to be done in the future is that this is the first version that we did of this framework in order to deploy secure network slices. And for sure, we'll find when we'll apply more tests and we'll reach a phase of a proof of concept, we'll find weak points. So our future work is to add some modifications to solve the weak points, and maybe the architecture might change in order to make all the flows simple, or because it's necessary to adapt in order to add other security functionalities. As I was saying, to not adapt it, the idea is to also make it more cognitive. And finally, if possible, if the architecture has to be modified, we will try to make it more simple while addressing interoperability and scalability issues that we may see. So this was everything. Thanks for your attention. Thanks to listen to me, and I will be happy and glad to answer any question that you may have. Have a good day, and thanks for everything. Goodbye.